Hello, and welcome to my overview of Purified Chapter 5 Future Water in Virginia. Today, we'll be talking a little bit about the issue of aquifer depletion in Virginia, a program with a potential solution, and some successes and setbacks of that program. So, why Virginia? Why does this chapter focus on Virginia, and what makes Virginia unique in our ongoing discussion about water recycling? Southeastern Virginia, where this story centers, is comprised of swampy lowlands, is located adjacent to the Atlantic Ocean, and gets on average 4 feet of rain. So, where do the water scarcity issues that we're used to seeing in these types of cases come in? When we compare southeastern Virginia with the American Southwest, it is immediately obvious that water scarcity is not going to be the main issue we're focusing on today. Instead, this region of Virginia is facing an entirely different water issue. Southeastern Virginia is home to the largest American naval base, the Norfolk Naval Base. This base sits atop the Potomac water aquifer that, due to overpumping, has become structurally unsound, causing the base to sink. In fact, the base has sunk 9 inches since it first opened in 1917. The Hampton Roads Sewerage District, which we'll be discussing in more depth in the slides to come, has an animation on their website showing the change in water levels of the Potomac aquifer over the last 3 decades. Here is just a snippet of that data, which was collected by the USGS. I compiled this to show where the most impaired areas are and how water levels have been evolving over time. Feel free to visit their website and click through the arrows yourself. The Norfolk Naval Base is located right here at the end of this arrow. Exacerbating the problems of in this area are rising sea levels due to climate change and also post-glacial settling of the earth. Combined with the aquifer overpumping, the ocean today is 18 inches higher at the naval base than it was a century ago. As you may expect, this causes all kinds of problems, limiting the ability of the base to work correctly and efficiently. In fact, these issues pictured here have been described as a national security issue because of the way that they impair the base. Clearly, these problems require solutions, which brings us to Ted Hennepin. Ted worked for the Hampton Roads Sewerage District, which services approximately 5,000 square miles around Chesapeake Bay, including the Norfolk Naval Base. When Ted began at Hampton Roads, he was tasked by the EPA with stopping sewage overflows into the Chesapeake Bay. Ted realized how expensive repairing and adding new technology to sewer lines and maintaining the repairs would cost. He estimates somewhere in the ballpark of $3 billion. To mitigate both cost issues, environmental issues, and solve the problem of the sinking naval base, Ted pitched the idea of SWIFT. SWIFT, or the Sustainable Water Initiative for Tomorrow, is a groundwater recharging program. The idea is that the drinking water plant will be added to the existing Hampton Roads Sewerage District plant. In total, the program has a goal of adding drinking water plants to 5 different wastewater treatment plants in the Chesapeake Bay area. Once wastewater is treated to reach drinking water standards, instead of being released into the Chesapeake Bay, it will be injected into the ailing Potomac aquifer. The Swift plant will implement the so-called East Coast method of water recycling treatment as opposed to the West Coast method. The East Coast method uses a granular activated carbon filter as opposed to the reverse osmosis treatment used in the Western United States. The East Coast method is typically cheaper and more energy efficient than the West Coast method. The East Coast method also does not have any harmful byproducts like brines that have to be disposed of properly. Because it doesn't have this brine byproduct, the East Coast method may be better suited to areas located inland from the ocean that are unable to dispose of the brine byproducts. Whichever way you slice it, both the East Coast and West Coast methods are possible solutions to growing water scarcity and treatment issues across the country. While the main goal of SWIFT is to help resist the groundwater depletion in Norfolk and Chesapeake Bay area, It also has the added benefit of reducing the amount of pollutants entering the bay from improper sewage treatment. In fact, it's estimated that the SWIFT program could reduce the amount of excess nutrients entering the Chesapeake Bay by nearly 75% once all these plants are up and running. Most notably, the SWIFT program has the goal of injecting 100 million gallons of drinking water into the depleted aquifer by 2032. This would effectively restore the aquifer to its natural state and prevent any further structural issues from developing. What makes Virginia's SWIFT program even more unique is the way that it was largely embraced by the public. Ted Hennepin understood the importance of early public involvement and encouraged public officials to endorse the project. He also held open houses and focus groups. Participants were even allowed to sample the drinking water. Today, Swift still offers virtual tours on their website, so if anyone is interested in touring a water recycling plant, I highly recommend visiting this website. They have tons of information in addition to this virtual tour. All that to say, involving the public and local officials was really important for Swift to get off the ground. But the SWIFT program also had the added benefit of not being the first water recycling program to exist in Virginia. The Upper Occoquan Water Service Authority, or UOSA, was founded in 1971. Before the founding of this program and before Clean Water Act regulations, the Occoquan Reservoir, which is pictured here, had been severely impaired by the dumping of untreated and improperly treated sewage wastewater. In order to remain a viable water source for the surrounding watershed, vast and sweeping changes had to be made to the way the sewage water was treated and disposed of. The Virginia Department of Environmental Quality created a comprehensive plan to solve this problem. The plan involved the creation of a water reclamation facility pictured here. This photo is a little bit grainy because it was taken shortly after the program's inception in the 1970s. But this plant had the intended purpose of treating wastewater and releasing it into the Occoquan River at near drinking water quality. Then, further downstream, the water was treated again. The implementation of this plan saved the Occoquan Reservoir as a drinking water source and was largely embraced by the public because of its success. Overall, the success of the UOSA project was pivotal to creating a positive public perception of water recycling treatment plants that was pivotal for the success of the SWIFT program. While all of that sounds great, the project has faced some trouble getting off the ground. Financial setbacks due to inflation have forced the program's developers to scale back their original plans, reducing the number of intended drinking water plants from 5 to just 2 or 3. They also have had to reconsider new timeline goals for meeting their aquifer injection goals. In wrapping up our discussion today, wastewater recycling isn't only applicable to water scarce areas, but also wetter areas that are facing different water related issues, such as those that we just saw in Virginia. We've seen in previous cases that public perception plays a major role in the development and success of these water recycling programs. And the SWIFT program had the benefit of following the OUSA project, but the program's founder, Ted Hennepin, still saw the importance of public outreach and involvement in the years leading up to the project's inception. Overall, the SWIFT program serves as an example of the ways in which water recycling programs can be successful. Now we just can keep our eyes on the project and see whether it is able to successfully meet those water treatment goals in the years to come. Thank you for tuning in.